Hello everyone, this is Srikanth, working as assistant professor in electrical department. Now, we'll discuss about classification of elements in electrical circuits. Generally, we have different types of elements we have. Now, we'll discuss few elements which are related to electrical circuits. So, network elements converted to active elements, passive elements, linear, non-linear elements, unilateral, bilateral elements, time variant, time invariant elements, as well as lumped and distributed elements. So we have some few different types of elements we have. Active elements. So active elements again divided into two types. One is independent elements and second one is dependent elements. So independent and dependent. So in that name we can observe independent elements and dependent elements. We can say like independent source or dependent source. And passive elements also divided into three types. Those are resistor, inductor and capacitor. You can say like three types of loads RLC. So passive elements are resistor, inductor and capacitor. Now again independent sources. So which sources we have independent? So independent sources again divided into two types. Those are ideal and practical. And again ideal and practical divided again two types. Those are so voltage ideal independent source, again current ideal independent source. So here we have independent source of four types. Same thing dependent source also. Same dependent source also four types. So here we have voltage dependent voltage source, current dependent voltage source, voltage dependent current source and current dependent current source. In independent sources we have four types. Those are ideal voltage independent source, ideal current independent source, practical voltage independent source and practical current independent source. So these are the some different types of elements. Now we'll discuss one by one. Active elements. So active elements are, it's a active, active means it's a energy given source. So the active elements are, it's a source of energy. It's a source of energy. So we'll give the some energy to someone. Okay. So active means it's a given source. So given source to someone. Active elements are deliver the energy. Okay. Those are the active elements. So some energy they will deliver. So examples are voltage and current sources. Voltage source and current sources. Again, voltage source are AC voltage we have as well as DC voltage we have. Again, current also. AC current and DC current. So we have DC source as well as AC source. Same thing in that DC voltage source and DC current source. And AC voltage source, AC current source. Okay. Now, active elements are again divided into two types. Those are independent and dependent sources. So independent source and dependent. In that name you can observe independent. So it's a independent source, not depending upon others. Dependent source means is depending upon others. Again, independent source are divided into two types, that those are ideal and practical. So ideal means it's a, in my words I can say like imaginary. Ideal means like imaginary and practical means which you are doing now. Again here ideal energy divided into two types, ideal voltage source and ideal current source. Same thing practical voltage source and practical current sources. Okay, ideal and practical. In ideal again two types, that is ideal voltage source and current sources, and practical also we have two types, that is practical voltage source and practical current sources. So independent again divided into four types. Those are ideal voltage source, ideal current source, practical voltage source and practical current source. So these are the independent sources. I will identify those sources. In ideal and practical, ideal source doesn't have internal resistance. Practical means we have some internal resistance. So where we are doing the practically, there we have some, suppose you are given 10 volts. So this is a 10 volts battery. But when you are doing the practical, some plus or minus values we have. So some internal resistance we have. Same thing, ideal and practical. So ideal means we don't have internal resistance, but practical means we have some internal resistance. That is the main difference between ideal and practical. So if you observe those images now. 1 and 2, 3, 4 images we have. So starting is ideal voltage source. Ideal voltage source. This is a voltage source. You can say like a positive and negative, no problem. So this is a voltage source, and I don't have any internal resistance. Coming to like second figure, this is the first one and second one and third and fourth. Now in first one we don't have any internal resistance, and second one we have some internal resistance. Okay, and coming to like a waveform, so there is no change of your voltage. It's a straight line. So when you have the internal resistance, then we have some changes. So some drawback is there. So same thing current source also. So it's a current source, the ideal current source, and this is the practical current source. In ideal current source, figure 3, that is the ideal current source. So current source means it doesn't have internal resistance. Okay, and coming to practical current source, we have some internal resistance. Just observe 2 and 3. So 2 and 4, observe 2 and 4 figures. In figure 2, voltage source series with internal resistance. And coming to fourth figure, current source parallel with internal resistance. Okay, so first one is voltage source series with internal resistance, but in coming to current source parallel with internal resistance. So there is a main difference. So when you have the practical voltage sources, then the voltage source has internal resistance with series. When you have the practical current source, the current source parallel with some internal resistance. Okay, the main difference between like ideal and practical voltage sources and current sources. Now, so already we discussed about independent sources. Now dependent sources. So dependent sources means depending upon someone. Independent means not depending upon any others. So dependent means it's depending upon someone. So we have again divided into 4 types. Those are voltage control voltage source or voltage control voltage dependent voltage source. You can say like dependent or control, no worries. So you can write like a voltage dependent voltage source or voltage control voltage source. Same as here, voltage dependent current source or voltage control current source. So here we have 4 sources. Those are voltage source and same voltage source, current source, current source. So voltage sources and these 2 are current sources. So voltage sources, which voltage source we have? Those voltage sources depending upon the voltage as well as current. Here depending upon the voltage and current. Same voltage sources. We have voltage source and voltage source. These 2 voltage sources are depending upon the voltage and current. Same thing current sources. Current sources depending upon voltage as well as current. That's it, simple. We have only 2 sources. Those 2 sources are divided into 4. That means voltage and current sources we have. This voltage source depending upon the voltage and current. And this current source depending upon voltage and current. That's it. We have 4 dependent sources. So here we have one and second one, third one and fourth one. So we have some different diagrams we have. So like first one, second, 3 and 4. We have 4 different circuits we have here. Now just observe one by one. So in previous case, if you see, the sources is like round, plus and minus. Same thing we have the direction. So where you have the plus minus means this is a voltage source, and where you have the direction means it's a current source. It's a round. If coming to like here, it's a diamond shape. Just observe diamond shape, diamond. So why? So where we have the diamond shape sources, those sources are dependent sources. So depending upon the someone. Okay. So where you have the diamond shape sources we have means those are the dependent sources. Just remember that word. So independent sources are like round and dependent sources are in diamond shape. And plus minus is that is a voltage, and where you have the direction, that is the current. Okay. Now we have the plus and minus. That means it's a voltage source. You have plus minus, it is a voltage source, that is a dependent voltage source. Okay, and same thing here. It's a direction is up. Some direction is we have upward direction or downward direction, but here upward direction we have the direction is with diamond shape source, that is dependent current source. This is the dependent current source, and coming to this is a voltage source again, dependent voltage source, and again this is the current source, dependent current source. Okay, now which is the voltage dependent, which is the current dependent? We will see one by one now. In first figure, so this is a voltage source. This is a voltage source. Voltage source is okay. Depending upon whom? Again, one more voltage. So, which voltage we have? VAB. Suppose it's a VAB. VAB is depending upon the VCD. So, VAB, that is a voltage source, depending upon the one more voltage. So, this is a voltage dependent voltage source. This is a voltage dependent voltage source or voltage control voltage source. It's a voltage source, but controlling by another voltage source. Coming to second figure, it's a current source. Now, dependent current source. This dependent current source, depending upon whom? Here, voltage source. So, this is a current source, depending upon the voltage. So, it's a voltage control current source. Or you can say like voltage dependent current source. It's a current source, but depending upon again voltage. Now, coming to one more third one, it's again voltage source. So, it's a voltage source, depending upon whom now? Current. So, it's a current control voltage source. It's a voltage source. Generally, it's a voltage source, but controlled by current. You can say like current dependent voltage source. Okay. Coming to fourth one, we have the current source. We have the current source, depending upon whom? Again, current. So, you can say like current control current source or current dependent current source. Okay. So, these are the four dependent sources. So, voltage control voltage source or voltage dependent voltage source. You can say like dependent or control. And second one is voltage control current source. And third one is current control voltage source. And the fourth one is current control current source. So, these are the dependent sources. Now, moving to like next one. That is a passive elements. So, we complete. So, dependent and independent. So, independent again we have the four. Ideal voltage source, ideal current source, practical voltage source, practical current source. So, coming to dependent, again 4. So, those are like voltage dependent voltage source, current dependent voltage source, and current dependent current source, and voltage dependent current source. We have the different types. Now, coming to like passive elements, again, passive elements are 3 types. So, passive elements means it's a consume the energy. So, which consume the energy? Those are the passive elements. So, here we have the resistor, inductor, and capacitor, and you can see like 3 types of loads. So, R, L, C, you can observe in practically like this. So, R, resistive, inductive, and capacitive. So, 3 different types of passive elements we have. Now, moving to like one more type, that is a linear and non-linear. So, it's a simple. So, linear means which elements satisfy the Ohm's law. You can say like a relationship between current and voltage. So, which satisfies the Ohm's law, those elements are linear elements. Not satisfied means those elements are non-linear elements. So, Ohm's law, we know that Ohm's law, I directly proportional to the V. I directly proportional to V, that is a Ohm's law. So, which elements satisfy these conditions? Nothing but those are the linear elements. Not satisfied means non-linear elements. And just observe the example also. So, linear elements are again resistor, inductor, and capacitor. Coming to like a non-linear, diode, transistor, and a transmitter, IGBTs. So, remaining extra. So, you can observe those pictures also here. So, like this. So, diodes, transistors, again diodes, and IGBTs, MOSFETs. So, all those things are non-linear elements. Okay, linear and non-linear. Again, we have more. Unilateral and bilateral. Simple. Unilateral means uni, so one direction. Bilateral means bi, means 2 directions. So, the current flow in one direction means those are the unilateral. Current flow both direction means those are the bilateral. Simple words. You can remember like this. Okay. So, unilateral means we have only one direction. So, those elements are, you can observe the example also. Same thing. So diode, transistors, IGBT, MOSFET, those are the unilateral. So only one direction current flow elements. And same thing, resistor, inductor, and capacitor. Those are the bilateral. So the current flow is both side. So those are the bilateral elements. Okay. So here, if suppose I have the resistor, the current flow both direction. You can connect any side, no problem. Coming to diode, you can connect only one side. So where you have the diodes. So diodes means we have only one current direction. So these are the linear, non-linear, unilateral, bilateral elements. Again, we have time variant and time invariant. So again, just observe those names. That's it. You can get the answer. Time variant, time invariant. So which elements depending upon the time. So if suppose time is increasing, the value will be changed. So those elements are time variant elements. So not depending upon time, those elements are time invariant elements. So depending upon time and depending upon the not depending upon the time. So you can observe here. So it's a depending upon time, the value will be changed. Some changing is going on. Coming to like time invariant, so the voltage is straight line, not depending upon the time. Okay, so time variant, time invariant. So which elements is depending upon time? Those are time variant elements, not depending upon time. Those elements are time invariant elements. Okay, and last one is like a lumped and distributed elements. Again, you can observe those names. That's it. So those are lumped and distributed. Lumped means it's a physically separated. You can say like it's those are elements are single elements, separately elements. Those are the lumped elements. And distributed means they are connected each other. They are connected each other. So those elements are distributed elements. So in that name also distributed. So where you have the transmission lines, there you can see those elements. Okay, transmission line. Same. Examples are same resistor, inductor and capacitor. In distribution also we have the resistor, inductor, capacitor. That's it. But lumped elements, those are the physically separated, and distributed elements are physically non-separated. So that's it. Simple difference between lumped and distributed elements. So this is about classification of elements. So we have different types of elements. We have active, passive, linear, non-linear, time variant and time invariant, unilateral, bilateral, as well as lumped, distributed. We have different types of elements. In that we have different elements we have. So this is about the classification of elements. Okay, we'll meet next class in different topics. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.